Andrew Message System. The Andrew Message System is part of the Andrew Project, a joint venture of Carnegie Mellon University and IBM Corporation. What you see on the screen is a set of X11 windows. The Andrew system runs as an X11 suite of applications and can also run on other systems than X11. Here we see a set of windows running under the TWN X11 window manager. The window of interest is the window on the right, the Andrew Message System window. This window is divided into three main panes. At the top, we have what we call the folders area. This is a list of mail folders and bulletin boards that are accessible for viewing with the system. Underneath that, we have the captions area, in which we have a series of one-line captions or short summaries of available messages in the highlighted folder. Finally, corresponding to the caption that is highlighted, we have in the third pane a message body, the actual text of a message in the folder. What we'll see in this demonstration is a set of messages that demonstrate the capabilities of the Andrew Message System using the system itself. In the beginning, electronic mail was an ugly thing. It all appeared in a single fixed-width font. It was monotonous to look at, and it strained the eyes. This was because early computer terminals only permitted single fixed-width fonts and gave very few formatting options. This led to a strange electronic culture in which emphasis was placed on words via devices such as surrounding them with asterisks or putting them all in uppercase, or occasionally by putting a space character between each letter in a word, or putting arrows around a word. These were poor expedients, but were the only options available to emphasize text in fixed-width electronic mail. With the advent of bitmap display workstations, the eye strain problem was reduced. Variable width fonts made it less painful to read electronic mail and other text on the computer screen. However, emphasis remained a problem. It was still necessary to resort to the devices just mentioned to emphasize words. With the advent of the Andrew Message System, it became possible to use multiple fonts to provide emphasis to different parts of a mail message. This initially had the effect of producing ransom notes and other messages that abused fonts to the point of decreasing readability, as this message does. However, in time, users of such a system learn how to use fonts tastefully and sparingly to emphasize key points in their message and to, in general, improve the quality of the communication. Including multiple fonts in mail suggested to many people further expansions of the functionality of electronic mail. If one can include arbitrary fonts, why not drawings? Here, for example, an Andrew message includes a drawing of the Carnegie Mellon University logo. However, because of the architecture of the Andrew toolkit with which the Andrew Message System is built, it is not necessary to stop at static objects, at pictures that are included statically in text. It is possible to include dynamic objects that will actually interact with the user. In the old days, one could always recognize high-quality stationery by holding it up to the light and looking at the watermark. In the electronic era, one can recognize high-quality electronic stationery by seeing how it animates. Indeed, the multimedia capabilities of the Andrew system are not limited to visual displays at all. It is possible, using the Andrew system, to send music and other media types through the mail. Here we see an electronic piano playing a crude rendition of a selection from Bach sent through the mail. Given these various options, one can easily ask, where will it all end? The cartoon character Mr. Natural, when asked the same question, replied, "In the grave, my boy, in the grave." This is probably the only place where the extension of media types in the Andrew system can end too. Because of the open-ended architecture of the Andrew toolkit, there is no fundamental limitation upon the media types that can be included in mail and documents. In fact, it is not even necessary to recompile applications in order to incorporate new media types. Currently, the Andrew toolkit supports line drawings, animations, hierarchical drawings, interactive tables, raster images, equations, and hypertext links. If appropriate hardware is made available, it is relatively easy to augment the system to support video, voice, or any other communications medium. Most applications will never need to be recompiled for such support.
When we started the Andrew Message System project in 1985, we had a set of goals, explicit goals, the foremost of which was reliability. The system in existence at the time was horribly unreliable. So in fact, people would send a message and then call you on the phone to tell you what in fact they had already put in the message. We realized that if the system wasn't essentially completely reliable, that people wouldn't use it and nothing else would matter. So reliability was our foremost goal. Secondly, we saw that multimedia capability was coming, in particular to Andrew, and therefore it was clear that we had to support multimedia mail and bulletin boards. In addition, though, lots and lots of people at CMU have correspondence over the ARPANET and BitNet and other networks which use ASCII-only mail. And so it was important that the system be able to handle multimedia mail and text-only mail in a transparent manner so that users needn't do anything special to deal with them. We're also concerned about scalability. We expected to support thousands of users eventually, and of course we do now. And in addition, we hope to support a lot of bulletin boards, essentially any bulletin board that anyone would want to create or acquire. And in fact, we now support about 2,000 bulletin boards from a variety of sources: the ARPANET, BitNet, NetNews, the Dow Jones Broad Tape, and locally created bulletin boards within Andrew and elsewhere on campus. So the system, in fact, scales up nicely. It also seemed crucial to us to support low-end workstations such as PCs and Macintoshes. There's a large number, I think well over 1,000 of those on campus, and we saw that they weren't going to go away, and therefore we should let them play as fully as possible in the mail game. And lastly, it's important that the system be administrable, so that in fact we could hand off administration to the computer center, and they'd be capable of in fact operating the machines as well as handling all the usual problems that occur with mail and bulletin boards. And in fact that's also occurred.
The Andrew message system is a complex set of software components that work together to provide a state-of-the-art mail and bulletin board system. The system as a whole is structured in a few high-level components. Messages are actually stored in a message database, which is not directly read by user interface programs. Instead, all access to the database is controlled by a message server process. User interface programs that wish to interact with the database do so indirectly through the message server process. Thus, for example, if a user wishes to send mail, he composes it with a user interface program. Once he is done composing the mail in the user interface program, the user interface consults a separate database called the white pages to verify the addresses of the recipients of the mail, and then gives the message to the message server for delivery into the database by a separate delivery system. For reading mail, the process works essentially the same way in reverse. The message server retrieves messages from the database and gives them to the user interface program. Of course, the system is actually considerably more complex than such a high-level picture reveals. Here we see a drawing made with another Andrew editor, the ZIP zoom-in picture editor, which shows the structure of the system on a basis of abstract machines. We see, for example, an Andrew file system file server, where messages may be actually stored in a database, a server machine where the message server process runs, and a client machine where the user interface process runs. These can be all the same machine in a degenerate installation, or in a full-fledged Andrew installation, they could all be different machines. In addition, there are connections to the external world made possible by post office machines, which translate between Andrew database format and the formats understood by the outside mail and bulletin board worlds. One can see more detail about this structure by zooming in using the ZIP editor to see additional details. When one chooses the zoom in menu, one sees, for example, that the post offices consist of filter programs that know how to speak various protocols to the outside world. One also sees that the message server machine is comprised of several separate processes, such as Guardian and Message Server, which interact indirectly with the database. One also sees that the client machine that runs the user interface software can be running any of a set of interface programs, the messages program which we have been seeing, or other programs such as the one called CUI or the one called VUI. In fact, the Andrew message system is designed to make it relatively easy to implement new user interfaces for reading mail and bulletin boards. Currently, there are 4 major supported interfaces. The messages interface, which we have been seeing in this demo, runs on Unix workstations, such as this IBM RT PC and a wide variety of other workstations. It can also be used from a Unix time-sharing system with an X11 terminal. At the other extreme is a program called CUI. CUI stands for Common User Interface, and it is a very low-level interface to the message system. CUI can be run on a teletype over a low bandwidth line or on virtually any other connection to a Unix machine. It can also be run on IBM PCs, Apple Macintoshes, and Unix and VMS time-sharing systems. And of course, it runs on the Unix workstations as well. In between messages and CUI is a program called VUI. VUI stands for Visual User Interface, and this program assumes that the user has a moderately intelligent video display terminal of the kind typically used for screen editors. This is a somewhat more sophisticated user interface and is available on the Unix workstations, IBM PCs, and on the Unix and VMS time-sharing systems. The Batmail user interface is an interface to the Andrew message system that works within the Unix Emacs text editor. It is available wherever Unix Emacs is available, typically on Unix machines. To demonstrate the visual appearance of the various interfaces, we have here pictures of the 4 interface programs all reading the same message. Here we see the Messages program, which we have been using, reading a message that contains a picture of 2 folk dancers. The message contains first some text and then the picture. The CUI interface, which can run anywhere, displays the same message in the following manner. It shows the information and the headers, the date, from, and so on, and then the text, Israeli folk dancing lives in Pittsburgh. But then, where the picture is supposed to be included, it says, an Andrew BE2 view, a raster image, was included here but could not be displayed. If the user chooses to print this message, he will see the picture, and he can also save the message and view it later using the Messages program. However, using CUI, he does not see the raw data of the picture, but instead sees this simple notice of omission. The VUI program, which is screen-oriented, has hierarchical menus at the bottom and is in general easier to use than CUI, but still does the same thing with multimedia objects. Here the picture was replaced by the same sentence that it could not be displayed. Finally, Batmail, the Emacs interface, looks like many Emacs interfaces, but knows how to replace the pictures with the appropriate message. One of the design goals of the Andrew message system was to support a very large database of messages. In particular, to support a very large number of bulletin boards to be available to all users of the system. In order to achieve this goal, the system was explicitly designed to function well on a large scale. To illustrate this scale, we have here an outline of the bulletin boards as they existed at Carnegie Mellon University in May of 1989. At that time, there were, for example, approximately 125 bulletin boards for academic use, for actual courses on the Carnegie Mellon campus. We had 123 bulletin boards that were used for discussion of the Andrew system itself, 51 bulletin boards for discussions of hobbies, and 415 bulletin boards used by campus organizations for various purposes. In addition to these locally originating bulletin boards, we had the Dow Jones News and Information Service, which feeds into the Andrew Message System database and comprises 109 of the Carnegie Mellon bulletin boards. An additional 373 of the bulletin boards originate as internet mailing lists but are viewed on Andrew as bulletin boards. And finally, all of Unix Net News feeds into the system as nearly 500 additional bulletin boards. The total number of bulletin boards available at CMU as of May 1989 was nearly 1,900. This is a very large number and indeed the largest known Andrew site, but other Andrew installations also have a large number of bulletin boards, and one IBM site has nearly as many as the CMU site. Of special interest is a tree of bulletin boards called magazines. Magazines are topic-oriented bulletin boards which have volunteer editors. An editor is a user who reads a large number of bulletin boards on a given topic and who has volunteered to select from those bulletin boards those messages that are of the greatest interest. Users who do not wish to read the complete, large, voluminous discussions on the source bulletin boards can instead read only the magazines and see only the messages selected by the editor as having the greatest value. With all of these bulletin boards, it can be very hard for people to keep track of new bulletin boards as they're created. In order to simplify this process, the Andrew Message System will, on occasion, invite users to subscribe to new bulletin boards as they are created. In particular, since the bulletin boards are tree-structured, whenever a new bulletin board is created, a notice is automatically placed on its parent bulletin board inviting new subscriptions. This message typically shows the body of the first message on the new bulletin board and offers a dialog box asking the user if he wants to subscribe. By simply answering yes, the user can subscribe to the new bulletin board. Of course, not subscribing is always an option. If the user is running a different interface, such as CUI or VUI, a dialog box is not used, but the same question is always asked. The idea of a message asking the user a question in addition to simply being read is one that recurs in several ways in the Andrew message system. This message, for example, calls for a vote. The user can read the body of the message and can then choose to answer the vote that has been included in the message. Whether or not a write-in vote is an option is up to the person who composed the vote. However, the option not to vote is always offered to the reader. Once the user chooses to vote, his vote is sent back as a mail message to a designated address, where the Andrew message system also provides tools for automatically correlating and tabulating the votes. There are several other types of active messages available on the Andrew message system. This message is a return receipt acknowledgement. The reader is automatically asked whether or not it is okay to tell the sender of the message that he did indeed receive and read the message. Other active messages include enclosures, which make it easy to transmit files around through the mail, and redistribution requests, where a piece of mail can be sent to one user and that user can be asked whether or not he approves of sending that message on to a wider set of users. Another design goal of the Andrew message system was to explicitly support a very large community of users. In most mail systems, users are addressed either by their proper names, in which case the system can't support a large number of Bobs or Smiths, or by a complex, hard-to-remember non-mnemonic name such as user K000, which is unique but is hard for the users to remember as corresponding to the person they're trying to send mail to. Here, we see the mail composition window of the Andrew message system. In the top is an area where one can type destination addresses and the subject of the mail, and in the bottom is an area where one can type the actual body of the mail. Of special interest here is what can be typed on the to or CC lines. Naturally, one can type a proper user ID. Thus, for example, if I type NSD and go to send the mail, or validate the mail, the address will be converted into its canonical form, in this case, my name and my user ID at my mail address. However, in addition to being able to send mail by user ID, one can send mail by proper name. Here, I type simply N. Borenstein, and the system, upon looking up this name, will find that there are actually 2 N. Borensteins in the database, and will give me the choice of Neil Borenstein or Nathaniel Borenstein. Beyond this name lookup, however, the system is also capable of doing phonetic matching. Thus, for example, if I type not Bronston, which is not exactly my name, and tell the system to look up this name, it will find my name and recognize that it was not an exact match and will ask me to confirm before sending the mail. In this case, not Bronston matched Nathaniel Borenstein, but not sufficiently closely.
The Andrew White Pages is a database of people and attributes about those people. Now, the Andrew White Pages for an installation of the Andrew system is a database of all the users of that system, all the people who can use that system. Now, with those people, we connect other attributes such as their login ID, their home directory, and things like that. This database is used extensively both in the user interfaces to the message system and to the delivery system itself. So in the user interfaces, for example, we use it to validate addresses, to validate the strings that people type as addresses, and make sure that they correspond to real users of the system. And we use it extensively also in the delivery system because we wanted to take the strings that we get as local names and turn them into deliverable pieces of mail, so that we'll know how to deliver mail to somebody's mailbox directory, or we'll know how to deliver it to their forwarding address. So the forwarding addresses are also stored in the White Pages for installation, so that when mail comes in for such and such a user, we don't deliver it locally, we deliver it elsewhere. Now, the Andrew White Pages also has a few interesting lookup features. We don't simply allow lookups by login ID or by name. We also do some more heuristic searches on names. For instance, we do abbreviations for those, we will match on abbreviations, and we'll also match probes heuristically, so that if somebody misspells a name in some pretty typical ways, we can usually find a match for that name in the set of all the Andrew user IDs. Or sometimes we get an ambiguous match and we have to report it as such.
When we demonstrate the Andrew message system for people, we of course like to show them all the fancy features like sending pianos through the mail and all the other extremely neat to look at things. But we didn't actually set out just to build a bunch of neat programs. Our real goal was to try to figure out what would make electronic communication more useful to people in general. And this sometimes involved non-technical things, what we call social experiments. In some cases, there were even features that other mail systems supported that we chose not to support because we thought that supporting them was a bad idea, that it was a negative impact on the general quality of communication. So, for example, a lot of mail systems allow you to use a pseudonym when you send mail, so that your mail shows up as being from the Masked Avenger or something like that. We disallow that. In fact, quite the contrary, we try very hard to authenticate all our mail so that mail from one Andrew user to another comes tagged with the real user's name and a very high degree of confidence that that's correct, that it's not forged. This means that our bulletin boards don't have conversations between Mr. Midnight and the Masked Avenger. Instead, people have to put their own names on what they say, they take responsibility for it, and that seems to contribute to a higher quality, friendlier conversation. Even putting hundreds of undergraduates together on a bulletin board, it usually stays polite when their real names are there. Another feature that we chose not to support was what's known as blind carbon copies. On a lot of mail systems, you can say, I want to send a copy of this message to someone, but not let anyone else know that he got it. It's like a secret copy that you send somewhere. Our feeling was that this decreased people's confidence that they knew what was going on with the system, that they trusted the system. And so we disallowed that, and people don't seem to have minded too much, at least. Another way that we experimented with the system is by trying to force people to think about where to post messages on bulletin boards before they actually post it. On a lot of systems, you'll have a bulletin board called General or Miscellaneous or something like that, where people can post anything they want. On our system, our users can create bulletin boards at the drop of a hat. We freely allow that sort of thing, but we don't allow them to create anything called General. They have to try and think of an appropriate category or an appropriate topical grouping and post their messages in that category. What this means is that you don't end up with a general bulletin board that contains a hodgepodge of really important stuff and totally useless stuff, and have people feel obliged to read it for the important stuff and then waste their time wading through the other stuff. By not allowing this sort of a kitchen sink for messages, by forcing people to think before they post, we save a lot of time, a lot of effort, a lot of reading unwanted stuff on the part of the average reader of the bulletin board. Another thing that we did that's kind of unusual in the system came about as the result of sort of a panic reaction on our part. We realized at one point that we were about to turn loose thousands of undergraduates on the internet. Now, the internet is the worldwide community of electronic mail and mailing list users that's mostly made up of researchers and graduate students and people like that. And we were, to our knowledge, going to be the first site to allow thousands of undergraduates access to this network. And we were a little nervous about that. We were afraid they'd start posting irresponsible messages and generally abusing the network and giving Carnegie Mellon a bad name and giving our software a bad name. So we were scared about that, but we wanted to give people access to this network. And after thinking about it for a while, we realized that most of the worst abuses of the system seemed to happen not maliciously, but through ignorance. People didn't know that, for example, you shouldn't send chain letters on an electronic mail network, which is a really bad thing to do. So what we did was, although we were willing to give access to all these undergraduates, we set them up initially so they didn't have access to the internet. All they had was local mail and bulletin boards. And we told anyone who wanted to know that if they wanted access to the internet, they had to read a certain help file. It was called the Networks Access Help File. What they found when they looked there was essentially an etiquette document. It was a list of do's and don'ts for network mail usage. Don't send chain letters, don't send commercial mail out, don't send nationwide mailing lists that have to do only with Pittsburgh, things like that. And they'd read through this 2- or 3-page document, and when they got to the end of it, it would tell them, now that you know these things, if you want network access, all you have to do is type the following magic command. It actually created a file in their home directory. So they could give themselves the access, but we required them to read this policy statement first. By doing that, we believe we cut back tremendously on the number of unpleasant incidents. We've had only a very few incidents of students doing stupid things on the network, and our observation of schools that have gone through this process differently is that we would have had a lot more problems if we hadn't gone through this required policy statement. So all our software enforced was that they had created this file and had therefore presumably read the policy document before they were given network access. Finally, the last problem that we think we solved via social mechanisms in the Andrew message system was the question of where do you go just to chat? In a lot of bulletin board systems, the important bulletin boards start to get filled up with garbage, people just talking about not very important things that aren't really relevant to the original purpose of the bulletin boards. And what you often find on such systems is people who become, either officially or unofficially, the B-board police. They go and they are always posting messages saying, that doesn't belong on the bulletin boards, don't post that kind of garbage here, we don't want to read it, you're wasting our time. Well, we were going to have thousands of people who could be policed, and we didn't want to be the police. So what we said is, how can we avoid the need for a bulletin board police? We didn't want to dictate how people could use our system anyway, but we wanted to have bulletin boards that were useful to people and not cluttered with junk. So what we said was, we would have a suite of bulletin boards called Graffiti, and lots of sub-bulletin boards, people could create them freely. And the idea was that on the Graffiti bulletin boards, you could say anything about anything, and nobody ever had to read it unless they liked graffiti. And the idea was that if you had a B-board police now, they wouldn't have to say, don't post this on the B-boards. They would simply say, you're posting it on the wrong B-boards. This turned out to be a very, very convenient mechanism. People react well to the notion of there's a place for everything, and they react better to that than they do to the notion of you're not allowed to say that. Another component of the Andrew message system that we believe significantly increases the productivity of those who read and send mail is a subcomponent known as Flames. You will recall that all access to the Andrew message system database occurs on the server machine by a process known as the message server. Embedded within the message server process is the language Flames. Flames, which stands for the filtering language for the Andrew message system, is a Lisp-like language with built-in primitives for manipulating messages. It can be used, for example, to specify the automatic classification of new mail as it is received on the basis of keywords or recipients of that mail. It can also be used to automatically delete certain messages, to automatically reroute them to appropriate people, or even to automatically answer messages.
Flames allows users to write programs for the message system in a dialect of Lisp to control the disposition of their incoming mail. For example, if I were a philatelist, I could have my Flames program scan the subject line of my messages for the word stamps or postage or whatever other buzzwords philatelists use. And based on what the Flames program found, it could file a message into my mail.stamps folder or mail.mountainclimbing or whatever. Alternatively, if the Flames program discovered that the message was from my ex-wife's lawyer, I could have the mail rejected outright with a little note saying the alimony check is in the mail. Flames is ideal for bulletin board processing, and as a matter of fact, the bulletin board system at Carnegie Mellon uses Flames exclusively. B-board posts are sent to a phony user called BB@Andrew, whose personal mail folders are really the campus B-board tree. A Flames program is run continuously over BB's mailbox, and messages are filed into the appropriate folders. And the occasional posting restrictions are enforced. Flames is also the basis for a number of mail-based services. For example, a user can send mail to an automated address saying, change my login shell, or subscribe me to the Info Andrew mailing list, and a Flames program responds without human intervention. Flames is a client of Eli, the embedded Lisp interpreter, which is a generalized library for building extension languages into larger applications. In the future, Flames will have the capability to perform arbitrarily complex operations on the entire mail and B-board database. For example, I could say, find me all messages on B-boards X, Y, and Z that are about surfing and have appeared within the last week in longer than 1,000 characters.
One of the less visible components of the Andrew message system is the Andrew Message Delivery System, or AMDS. The message delivery system is simply the component which delivers mail or bulletin board messages to their intended recipients. Overall, the Andrew message system is designed to work with several such delivery systems. The delivery system is thus an optional component. However, a new delivery system was implemented as part of the Andrew message system because it was found that all existing message delivery systems did not work reliably or efficiently in a distributed file system environment. The Andrew message system is designed to deliver mail reliably and efficiently using multiple backup queues, even in the presence of partial or total failures of network resources. In general, a message is composed on an Andrew workstation such as this one using a user interface of the kind we have been seeing. When the mail is to be delivered, in the simplest case, the mail is simply written as a new file into the mailbox of the recipient user. The mailbox is a directory in that user's own area on the file system. However, this is not always possible. Certainly it is never possible if the intended recipient is not a local user. It is also not possible if the user's home directory or mailbox are inaccessible due to file system or network problems. In that case, the mail can be enqueued in a queuing directory on the Andrew file system. Once enqueued in such a directory, the responsibility for delivering the mail is transferred to the post office machines. Privileged daemons, running as the postmaster user on the post office machines, periodically poll each of the mail queues in the file system and attempt to deliver the mail found there. Mail for local users will be delivered, if possible, to a local mailbox. If the mailbox is unavailable, mail will simply be left in the queue until the mailbox becomes available. For remote mail, mail destined for non-local sites, the post offices are capable of doing delivery using a variety of network protocols. In particular, SMTP, the Simple Mail Transport Protocol used on the Internet, is supported, as is the NNT protocol for delivery to NetNews, and for incoming Dow Jones messages, a special Dow Jones protocol is also understood. The system is also designed to be easily extended to understand other protocols. Mail to be delivered using external protocols to the outside world is sometimes temporarily enqueued on the local disk of a post office machine. Finally, a worst-case scenario not yet discussed is mail composed on an Andrew workstation that cannot even be enqueued because of a total network or file system outage. In such cases, the mail is temporarily enqueued on the local disk of the workstation, and a local daemon will continue to poll that directory and will eventually copy it into one of the file system queues. However, this is a last resort scenario because mail that is written onto the local disk is not authenticated to the Andrew file system. Whereas in general, mail sent with an Andrew interface is considered to be highly authenticated and trustworthy, mail that is enqueued on the local disk is considered unauthenticated and possibly forged and is always flagged as such so that the recipient will not be fooled.
When we started the message system project, we considered the delivery system to be kind of this necessary evil underlying everything, but we figured it would be pretty simple to take care of. I mean, after all, Unix came with a delivery system, and we probably didn't need anything much different. Well, it turns out that a year later, the two of us were still working on the delivery system, and in fact, we hired a third person to help us. It turns out that because of the distributed nature of Andrew, lots and lots of workstations, autonomous workstations connected on a network, and also because of the central file system, that the delivery system was much more complicated than we thought. I mean, in particular, the central file system introduces a number of new error modes for dealing with files. So it's possible for there to be a temporary error where a file is temporarily unavailable because the file server's down. That doesn't occur normally on Unix. And so essentially all of the standard Unix software is just unsuitable for our environment. So it required a lot of rewriting and kind of a lot of clever distribution of where knowledge is on how to deal with messages and temporary errors. Now that's all been accomplished, but in fact it was a great deal more effort than we thought.
In order to appreciate the scale of the Andrew message system, it is useful to look at some current statistics from the Carnegie Mellon installation of the system. As of May 1989, there are on the Carnegie Mellon campus approximately 1,900 bulletin boards that are either publicly readable or readable by a large segment of the population at Carnegie Mellon. The typical Carnegie Mellon user subscribes to approximately 40 bulletin boards, although one user is known to subscribe to 468, and subscribing to several hundred is by no means uncommon. Moreover, several of the people who subscribe to this many bulletin boards do other things as well and get productive work done in addition to reading bulletin boards. Currently, messages are pouring into the Carnegie Mellon database at the rate of about 10 gigabytes per year, and a new message shows up on some public bulletin board every 22 seconds. There are currently 34 user-edited magazines available at Carnegie Mellon, and the number of registered Andrew users at CMU in all is 8,400. Of those 8,400, approximately 3,100 use the Andrew message system virtually every week to read mail or bulletin boards. Finally, another measure of the distribution and scale of the Andrew message system is the number of non-Carnegie Mellon sites that are using the system. This number is hard to gauge because the system is distributed freely to anyone who wishes to receive the X11 distribution from MIT. However, there are 33 non-Carnegie Mellon sites that subscribe to a multimedia distribution list based at CMU. Therefore, at least that many sites are regularly using the system to read multimedia mail. A few additional features and ongoing developments are also worth mentioning. Another group at the Information Technology Center at Carnegie Mellon has developed a toolkit for processing ODA, the Office Document Architecture, an emerging standard for multimedia document interchange. This toolkit makes it possible to translate some Andrew multimedia documents into other multimedia formats. It is our hope to eventually translate between Andrew multimedia messages and the multimedia format of various other multimedia systems as they become available. Another area of ongoing work is with the white pages technology. The white pages have proven sufficiently popular that we are working on generalizing them to address the issue of national naming. In particular, we are collecting electronic mail addresses as they pass through our post offices and are building a database of network addresses against which the names users type can be matched heuristically. We thus hope to get some of the white pages functionality even with regard to addresses that are totally unrelated to the Andrew system. Also going on at Carnegie Mellon are efforts to enhance the client base of the system to provide a higher level of functionality and more interfaces for the Macintosh and VMS environments. Finally, also worth mentioning, the Andrew system includes a general-purpose calendar facility called CHAMP, which has some unusual features such as support for non-Gregorian calendars. A simple messages option makes it easy to view the events you've scheduled with the CHAMP system on your messages startup screen. The Andrew message system was designed by Jonathan Rosenberg, who also managed the Andrew message system project, Nathaniel Borenstein, and Craig Everhart. In addition to these three, major implementation effort was performed by Adam Stoller, Bob Glickstein, and Mark Chance. Beyond these 6 principal implementers, however, the Andrew message system represents a great deal of work on the part of many other people who have worked on other components of the Andrew system which are vital to the success of the Andrew message system. As you can see here, this list of people is virtually a cast of thousands.